You are welcome back to Better's channel, a channel whereby basic foundation is given to you about mathematics and physics, and they will be explained to you in its content. Now, at the earlier stage of it, we are discussing about units and measurements. Now, in this part of it, we'll be discussing about what we call the derived quantity. The derived quantity. And don't forget to subscribe to this YouTube channel so YouTube will notify you whenever a new video is being dropped. The fundamental quantity and the use of SI unit. Now in this segment we'll be dealing with what we call the derived quantity. Remember that derived quantity are those quantities that are obtained by simple combinations of two or more fundamental quantities. And remember the first video we talked about fundamental quantity. An example of fundamental quantity is what we call the length, the mass, the time, the temperatures, and others. So from here we'll be dealing with the derived quantity as the first segment. We have the other part of it which we call the derivation. The derivation, and we have the last part of it which we call the units or the derived unit. So from here, this is what we have. Remember that we have this as the first, which we call the area. And the formula for area all over in mathematics and in physics is given as what? Length times what we call the breadth. The SI unit of length is what we call the meter. The SI unit of breadth is what we call the meter. These two things falls under the use of what we call the length, and they have the same SI unit as length. So we have length times breadth, which is meter times meter will give us the SI unit as what we call the meter square. Obeying the law of indices, law 1, which states that whenever two alphabets are having the same base, pick one of the base, and what will bring these two powers together is what we call an addition sign, which is what? A plus B. Now, for the second law of indices states that whenever two powers are having the same base, and one separates each of these bases from each other is division sign. When we attract these two powers together is what we call a subtraction sign. The reason is because what separates these two known bases together from each other is what we call a division sign. So we have it as equals to, choose one of the base, A minus B. So from what we have here, M times M equals to M squared. We have the second one of it, which we call the volume. Formula for volume is given as what we call the length times breadth times the height. The SI unit of length is what we call meter. SI unit of breadth is what we call meter. SI unit of height is what we call meter. These three things has to do with the distance between an object. So meter times meter times meter. The M times M times M. Pick one of the M halves as this. Then what separates each of these M from each other is what we call the multiplication sign. So what will bring each of the powers together? M what? M cube. So we have the third one as what we call density. Formula for density is what we call mass all over volume. SI unit will be what? SI unit of mass from the fundamental quantity is what we call the kg, and for volume from what we have here is the same as what? Meter per cube. The reason why we are having a subtraction sign acting as a power is because this volume here is acting as a denominator. So we have the fourth one as what we call velocity. And the formula for velocity is what we call the displacement all over time taken. The SI unit for displacement is what we call the meter. SI unit for time is what we call seconds. So This x here is having a minus sign. The reason is because this time here is acting as a denominator. Never forget that there's a differences between what we call distance and displacement. So distance has to do with the space between an object from each other, the scalar quantity and the vector quantity. What are scalar quantity? Scalar quantity are those quantity that has a magnitude. They have a specific size, but it does not have a specific direction of where they are going. So we have mass is an example of a scalar quantity. All the examples of fundamental quantities are examples of scalar quantity. The reason is because this quantity has a specific size or magnitude, but it does not have the direction they are going. So from there we have what we call the vector quantity. Vector quantity are those quantities that has both magnitude and direction. That is to say, they have a magnitude and they have a direction at which they move. So this displacement is an example of what we call a vector quantity. So we have the fifth one, which we call acceleration. In some cases in motion, we call it acceleration due to gravity. The expression for acceleration is what we call change in velocity. Change the velocity all over the time taken. All over the time taken. And the SI unit is what we call meter per second squared. So from what we have, we said force. The derivation for force is given as mass. Mass times acceleration. Acceleration due to gravity. The SI unit for mass is what we call kg. SI unit for acceleration is what we call meter per second squared. So, but on a normal note, textbook has been giving us that, has explained that the SI unit for force is what we call Newton, the N. But using the derivation quantity, we can also say the SI unit for force is the same thing as kilogram meter per second squared. So we move to the seventh one, which we call the work or energy. Work and energy shares the same similarities. It shares similarities between themselves, and the formula for work or energy is what we call force times the distance. Whenever you study the concept of work is said to be done whenever a force is being applied to move an object from point A to point B in a distance. That is to say, the formula for work or energy is what we call force times distance, and the SI unit according to energy is what we call joule. But using the derived quantity, we can also call it Newton meter. The N is from the force, while the M is from the distance. So we have the work done. Work done all over what we call the time taken. And the SI unit for power is what we call watt or joule per second. We have the ninth one as what we call the pressure. The formula for pressure is given as force all over area. And the SI unit for pressure is what we call Newton per meter cube. So we have the last one, which we call the momentum on its own. So remember that momentum is defined as the product of mass and its velocity. All these derivations you have at the center can be used to give a specific definitions to each of these derived quantity. Now, we have the formula for momentum as mass times velocity. The SI unit of mass is what we call the kg, while the SI unit for velocity is what we call meter per second. When these two things multiply themselves together, it gives us kilogram meter per second. So remember that from the derivations of what you have at the center here, it can be used to give momentum a given definition as something like this. Momentum is defined as the product of mass, of its mass and its velocity for that. And that of power is the same thing as power is defined as the time rate of doing work, and so on and so on. So thank you for staying with us. I believe has gone so much help us. This is where we are going to end. this segment for derived quantity